Okay, we're looking at mixed exercise 8 from the first year core textbook. So we're on question 13. Again, this was quite a bit different to the previous ones because now we don't know the power. And that does, I think, tend to be a little bit trickier. So we get the formula sheet up. Okay, so binomial expansions, we've got two unknowns. We've got the k there, and then we've got the power of n. And the coefficient of x squared is equal to the coefficient of x cubed. Right, well, so let's have a think about what our x squared and our x cubed terms would be. So I'm doing 2k plus x to the power of n, and I think we are going to sort of need to, look at the formula sheet quite a little bit for this one. So obviously, so for us, a is 2k, b is x, and n we're calling n. So my squared term, so obviously if b is x, this is my x squared term. So it's going to be n choose 2. It's going to be b squared and 2k to the n minus 2. Okay, so I'm looking at that term there, and I'm literally just substituting in the information we've got. So we're still calling nn. Our a is 2k and our b is x. So there's my x squared term. My x cubed term is going to be n choose 3. Now, they don't actually specifically tell me the x cubed term, but you've used it lots on more standard questions. So the power of a is going to reduce by 1. So that will become 2k to the power of n minus 3, because that power needs to go down by 1. And then the x term is being cubed. Now, be really careful. It's tempting to put that they equal each other, but they don't. And this is a proof question. So the last thing you want to do is lose marks for something like that. So they don't equal each other. Their coefficients equal each other. So so the coefficient of x squared is n choose 2, 2k to the n minus 2, and the coefficient of x cubed is n choose 3, 2k to the n minus 3. And I would suspect that we haven't got a broken down mark scheme for this, but I'm sure you would be on your first method mark by that point. Okay, so we are going to have to use this formula here, which you don't often have to use. Normally it's just a case of plugging it into your calculator, but when you don't know the power, that's when you may have to use this formula. And that's actually not so bad. It's not the easiest thing in the world, but it is something that does come up quite a bit, so you should get some practice of that. The other fiddly thing are these the k's. So I think the best thing to do there is just think about how these powers compare to each other. So imagine if it was just something a lot nicer, like that was 2k to the power of 4, then regardless of the brackets, I'm not really worried I'll put the brackets in, but they don't really affect the point. And then this was 1 less, so this was 2k to the power of 3. What you could do there is cancel through by the cubed, by the 2k all cubed, and you'd just be left with 2k. So if I do the same thing here, I can cancel through. So effectively, I'm cancelling through by 2k to the power of n minus 3, and that will just leave me with 2k. Okay, that's probably the fiddliest bit of this question. Right, so now on to those n choose 2 and n choose 3. Well, let's have a think about this formula. So the formula is n factorial, the numerator, all over r factorial. So 2 factorial for this one, and then n minus r factorial, and I've still got a 2k on the left-hand side. So using the same thing for the n choose 3, it's n factorial over 3 factorial times n minus 3 factorial. Okay. Right, so then we need to think about what factorial actually means. So n factorial on those numerators means n times n minus 1 times n minus 2 times n minus 3, etc., etc., etc. 2 factorial is just 2 times 1, so that's just 2. And then n minus 2 factorial is n minus 2 times n minus 3 times n minus 4, and so on and so on. So what is going to happen? Oh, and then I've also got the 2k on the left-hand side. And then that equals, so we'll worry about the right-hand side in a second, because what is going to happen is everything below n-2 in below is going to cancel. I've got an n-2 numerator and denominator, n-3. I didn't bother writing it, but there would have been an n-4 there, and then everything down to 1. So actually, so that n-4 would cancel. And in fact, whilst I'm having a bit of cancelling fun, that 2 and that 2 can also cancel. So I end up with the n times the n-1, and then just the k, and everything else is cancelled. Right, so we try and do the same thing on the right-hand side, so looking at this fraction. So I've got n factorial, so that's n times n-1 times n-2 times n-3, and so on and so on. 3 factorial means 3 times 2 times 1, so that's just 6. And then n-3 factorial will be n-3 times n-4, and so on and so on. So again, I'm going to have a lot of cancelling. n-3 and below are all going to cancel. So I'm left on the right-hand side, sorry, with n-1, n-2 all over 6. Now, don't be tempted to start expanding out, because I think that will end up as a bit of a nightmare. I can also now cancel both sides through by n and by n-1. And now is the payoff, because that is all I am left with. So I can then multiply up by the 6, add the 2 over, do the huge sigh of relief, and say, as required. So that is not an easy question, that one. It was a bit mean, I think, putting those 2 k's in as well as having the unknown power. So this bit is the most important bit. This is the bit that's most likely to come up for this type of question. Okay, I don't even think that was the whole question, was it? No. Okay, so given that k is 2/3, yeah, so I suppose the good thing about this question is you could answer part B not having answered part A. And part A actually was only worth 3 marks. So never sort of just give up on a question. Always read the whole thing, because basically they've told us that k is 2/3. And then even if we haven't proved it, they gave us that result as well. So n is 6 times k plus 2. And we know n has to be an integer, because we only deal with integer powers this year. So that is going to be 12 over 3, so 4 plus 2, so n is 6. So part B is actually a lot nicer. So 2k, oh, there, 2, far too much by linear expansion. Where are we? Okay, so, right, so 2k is going to be 2 times 2/3, so 4/3, plus x, and then to the power of n, which is 6. And we only need to go up to x cubed, then we've just got to simplify. So hopefully we don't need to keep looking at the formula for this type of question, but let's have it up just in case. So it's going to be a to the power of n. Be really careful to make sure your fractions are fractions and your NCR is not using the right notation. So that's a to the power of n. That's my first term. And then it's going to be plus n, choose 1. The power of a is going to reduce by 1. And I will have my first x term. Then it's going to be 6, choose 2. 4/3, and the power will reduce by 1. And the power of x will increase. And then 6, choose 3. The power of 4/3 will reduce by 1. And the power of x will increase by 1. And for any individual term, powers should all add up to 6. Obviously here, that is x to the power of 1. We just don't bother writing the power of 1. Okay, and then I'm just going to be careful with my simplifying. So the first term hopefully is all right. That's just 4/3 and then to the power of 6. So 4096. Oops, I can't see. Let's move this whole thing up now, can't I? So 4096 over 729. That is just that term there. Okay, and then so careful with the next one. So it's 6 choose 1, so that's just going to be 6 times 4/3 to the power of 5. So I'm getting that as 2048 over 81. That's my x term. So then my x squared term is 6 choose 2 times 4/3 to the power of 4. So 1280 over 27. And x cubed, so 6 choose 3 times 4/3 to the power of 3. Yeah, I'm getting that as the same coefficient. Check that in the answers. So I've just typed the same thing in twice. That's what I am getting. It did say simplify the fractions, but obviously I've put that into my calculator, so they will be simplified. So it's more just if I've typed something in wrong. No, I think we're okay. So notice, oh yeah, so actually there's their working. You can have a look through. And notice even though B was worth 1 more mark, obviously I haven't shown all the working for B, but I think it still was quite a bit easier than part A.